Problem number 1745, Palindrome Partitioning Part 4. Okay, so it's another palindrome thing. Given a string as return true. Okay, so it's true, false. Return true if it is possible to split the string S into 3 non-empty palindrome substrings. Otherwise, return false. Okay. Okay, so it's a true false thing. I'll say if we'll check the last one first. So we'll start from last number, as character first. So if si is selected, problem strings to si, like not including si, just into substring. Yeah, and we will try to find the palindrome in this substring. So, and there are multiple ways to partition the array. So maybe we can do like si minus 1 and si, like the last two elements are selected. And the problem shrinks to si minus 1 till I said. So we can write like if sj till I are selected, problem shrinks to sj. Then that's still with this like 3 it should have 3 palindrome substring. And it is a true false question. So if this part are selected, so like if the suffix is are selected, it is, then for this problem we will only have to find 2 partitions for the rest of it. So first of all, the length of this thing should be larger or equal to 2. And so if this is selected, yeah, like in the previous question we have k, so that's now k is 3. So the length of the length of the string will be at least 3. Yeah, like the most brute force way that I can think of is, well, we will have 3 as k, then I for the last index of array of the subarray of the partitioning array. So it will be dfs3 is like whether S till I, whether substring can be partitioned into palindrome substrings. Can be partitioned. Whether substring Si can be partitioned to 3 palindrome substrings. Okay, so DFS 3I will be and we have to add condition. If Si is selected and if Si is a palindrome, then problem shrinks to, so for this J till I is a palindrome, then the problem can shrink. So we'll have like time complexity will be 3 multiplied by n like there are n kind of length of the substring, and for each length of the substring we have to do an n selection and check to see if it is a palindrome. Yeah, and for palindrome we can do we can first like make a matrix that the row will be the left boundary and the column will be the right boundary. So, and we can check if it is a palindrome. Okay, so that's we'll have to do first for palindrome matrix, and we'll first have n will be the length of string, and we will start with the DFS recursion. We'll have k. Well, let's say we'll have k, and k is 3. So have if k is smaller than 0, then we have nothing to partition. So if there are leftover elements, leftover characters, then it is invalid. So return true if I is smaller, okay, we'll say I smaller than 0. And if I smaller than 0, yeah, if we have nothing to partition, then k should be 0 as well. Yeah, like if I let's see, if I is 0, then we have nothing to partition. Okay, so then we will try each way of partitioning for I, the length of I, subarray, substring. Okay, so we'll have edit. We'll say false first. So between, like, for this selected and the rest of the problem, it is an AND operation, since we want the selected thing is a palindrome, and also the rest of the problem is also palindrome. But we only need one way, like one partition way to be valid. We don't need every partition way to be valid. So we'll have false for default, and we'll loop through the partition ways. So for j in range n, I, yeah, since j should be smaller than I, and then valid will be, or okay, the rest of the problem will be dfsj, and the selected part is a palindrome. So we'll say palindrome like we have a metric is palindrome, we'll have we'll say we'll have true equals n matrix. So so on the left is j, like the starting will be j and the ending will be I minus 1. Oh, this should be k minus 1. Yeah. And return dfs 3 and n. the palindrome matrix. It's a bit say for I in range, or say for L. So L in range let's see, we will have I equal to I since we are accessing the string, we'll have n for R in range n as well. Is palindrome equals LR is palindrome L plus 1 and R minus 1. And you should check if like yeah, we should check SL equal to SR. So if both of them are equal and the rest of it are equal, then it is a palindrome, else it will be false. Let's see if we do a check first. If this is a palindrome, I think this will be better, like faster. If it's palindrome, then we will check. If not, then we don't have to check. If it is a palindrome, let's check the others. Then yeah, else we will have valid false. And for this, it's like the metric, it should start, it is asking, like LR, it is asking for the next row and the previous column, like the left, the lower left, lower left node. So we have to start from bottom. Yeah, like we have to start it from bottom, so it will be n minus 1 till 0. And for R, yeah, it can be yeah, this order will be good since it needs the previous node. But I'll say because L should be larger, no, should be smaller than R. Smaller or equal than R. So R can be started, like R can start it from L. No need, since when equal to R, it is always true. Okay. Then, yeah, not sure if it will touch the boundaries. Let's see. If L is n minus 1, so it will have n. Oh, not good. How about starting from n minus 2, since n minus 1 will be, yeah, n minus 1 was and will not work. Yeah, but started with here is, I think like it will not work, so it's fine. And that's CR. So so this is 0, then okay, L is nothing to worry about. Well, R, the upper bound is L plus 1, so it will be L here, and L plus 1, yeah, it can be, okay, it like, this one is, if this is L, then okay, the smallest, okay, so largest will be n minus 1. Yeah, it will not be L. Okay, let's check. Oh, 3 mistakes.